Okay, so let's move on to this next section. This next section has two different identities going on, two different formulas going on. One is called product to sum, and the other one is called sum to product. So, I've written them all down because there's really no easy way to remember them all. This is where, in the real world, you would actually have a book to use as a reference. The only thing I can tell you, and you're like, one of them has 3 identities, the other one has 4. Here's the deal. The one with 3 identities, it multiplies 2 sines together and 2 cosines together. And here, it multiplies 1 cosine and 1 sine. And remember, it doesn't matter the order in which you multiply things because you get the same answer, which is why they did not write a 4th one with these guys flipped in reverse order. All right? On the sum to products, remember, you can only add things that are the same. So we're adding 2 cosines, we're adding 2 sines, we're subtracting 2 cosines, we're subtracting 2 sines, but you can't subtract a cosine and a sine. Got it? Okay, so my recommendation is you pause the video at this point and either take a picture of these things or write them down, but I suggest pausing them and getting these in your notes. And I'll be... Okay, so let's look at these next examples. These first 2 ask us to express these following products, because these are multiplication problems, as a sum. So here's the deal. You need to find the appropriate formula that takes the multiplication of these 2 signs and turns them into a sum. Now, when I found the correct formula, the appropriate formula, I am going to rewrite this as 1/2, and in brackets, I've got the cosine of 4 theta minus 2 theta, and I'm subtracting the cosine of 4 theta plus 2 theta. And when I simplify this, I end up with the cosine of 2 theta minus the cosine of 6 theta. And some of you are going, well, is that it? So, just in case any of you are thinking of this, if you distribute the 1/2, do you distribute the 1/2 to the entire cosine of the angle or just to the angle? Yeah, the entire cosine. So in this case, it doesn't make a difference for us to distribute the 1/2. That'll be the answer. And some of you are still asking, that's it? And I'm saying, yeah, that's it. Now let's look at number 2. Now I'm multiplying 2 cosines and they want me to write it as a sum. So when I find the appropriate formula, it looks like 1/2. And in brackets, I'm going to write cosine of 5 theta minus 8 theta added to the cosine of 5 theta plus 8 theta. And when I simplify it, I end up with the cosine of a negative 3 theta plus the cosine of 13 theta. Good? Okay. You're like, that's it? There we go. Let's look over here, okay? These 2 problems want me to take this subtraction instead and write it as a product. So I need to turn these into multiplication problems. So I'm subtracting 2 sine functions. So when you find the appropriate product, this is what I found it to be. I'm going to take 2 sine of, let's see, 8 theta minus 2 theta divided by 2. And I'm going to multiply it by the cosine of 8 theta plus 2 theta over 2. So I end up with 2 times the sine of, let's see, that's 6 theta divided by 2, 3 theta, times the cosine of, that's 10 theta over 2, 5 theta. And again, I know some of you are going, is that it? Yeah, that's it. Don't read a whole lot into these particular formulas or identities as they're also called, okay? because these are very simple to work with. They're not easy to remember formulas by any stretch of the imagination, considering they all look so similar, but they're pretty straightforward. So just like the other ones, so don't read too deep. Okay, so now I'm subtracting two cosines, and I'm trying to put it into a product. So when you find your appropriate formula, hopefully it looks like the one I'm writing. So we're going to have 3 theta over 2 plus 5 theta over 2, and this whole thing is divided by 2, isn't it? Times the sine of 3 theta over 2 minus 5 theta over 2, and again that whole thing is divided by 2. Alright, so let's see. Negative 2 times the sine of, so look at the numerator. What's 3 theta plus 5 theta? 8 theta. So I'm adding these two fractions, right? 8 theta over 2, which is what? 4 theta. Divided by 2 one more time, right? Yeah, that's 2 theta, but you know what? I'll do this. So the numerator is 4 theta, and this 2 is this 2 here. And let's do this. What's 3 theta over 2 minus 5 theta over 2? Negative 2 theta over 2, which is negative theta, and divided by 2, this 2 is this 2. This one can be simplified, can't it? So hopefully you ended up with the same thing I did. Cool? Okay, hang in there. I got a verification problem for us. Okay, they're asking us to verify this identity. Remember the ground rules. You can't move anything from the left to the right, and you can only work one side at a time, right? Okay, so I'm going to work with the left side because that looks like it has a lot more stuff on it. So when I look at the left side, I'm going, gee, I see sine over cosine, both at the same angle. And I see sine over cosine, both with the same angle. I think I'll split them apart. And the challenge is you can't. Why? Because you have this lovely addition sign in the middle holding them together, which says you can't pull these apart. So I don't know about you, but I'd rather take these addition problems and make them into multiplication so I can look at them separately. So how do I take an addition problem and turn it into multiplication? That's right. We need a sum to product formula. So you go find yours. I've already found mine, and hopefully we agree. By the way, I'm not going to show you all the steps. I'm going to show you the final result after I found the correct formula. So I end up with the sine of 6x plus 2x is 8x, right? Divided by 2 is 4x. That's how I got the 4x. And then 6x minus 2x is 4x. Divided by 2, 2x. So that's how I got the numerator. Good? The denominator, the formula I found was cosine of, so I'm going to take 6x plus 2x, 8x, divided by 2 is 4x, and then I'm going to take the cosine of 6x minus 2x, 4x, divided by 2, 2x, equals that side. Okay, do you notice what happens? Yeah, the 2's drop, because this is all multiplication now. The 2's drop, the cosine of 2x's drop. I'm left with the sine of 4x over the cosine of 4x. And gratefully, that's the tangent of 4x, which is exactly what I have on the right side. Check! Verified. Cool? I know, I went through that one a little bit quickly. So go back and replay it if you need to. But you have fun with these sum to product and product to sum formulas, and I'll catch you on the flip side.